Hello everyone and welcome to this video. In today's video, we'll be learning how to build with NEAR. This is actually going to be a three-part series where in the first part, we learn about how to read the smart contracts and set up the development environment. In the second part, we'll write our own smart contract. And in the third part, we'll learn to write unit tests for the smart contracts. Now, the NEAR blockchain has been picking up a lot of traction, primarily because the NEAR ecosystem offers a lot of great features for those who are wanting to build dApps on top of blockchain frameworks. NEAR is also, according to a recent report, it is extremely environment friendly as well. And it offers programming languages such as AssemblyScript or Rust, in which you can program your smart contracts. The NEAR ecosystem overall is quite friendly, and there are guilds across the globe helping those who want to onboard to NEAR. So if you want to learn more about NEAR, I will link a couple of other videos in my description box, which could be helpful as well. So let's get started. So for all of you who are watching me for the first time, my name is Lakshmi, aka Gyan, and I'm one of the ambassadors for the NEAR India Guild. I'm one of the core team members. I love building educational material. I love building videos, recording tutorials, and of course, I love learning about blockchains, right? So without further ado, let's get started. So this is the first part of the video series where we are going to be cloning a small repo and just walking through one of the contracts. As I already mentioned, as a part of this series, what would you be learning? In the first part, that is this video that you're watching, you'll be learning what do you require to set up to develop and build NEAR smart contracts. We will be reading one of the contracts and walking through the different functionalities of the contract. In the second part, we'll be writing our own contract. You'll learn how to write a contract from the scratch. And in the third part, of course, to complete the loop, we'll be writing some unit tests. So the contract language that we'll be focusing on would be AssemblyScript. You can also write contracts on NEAR using a Rust language, for which we'll be doing a separate series pretty soon. So without further ado, let's get started. So like I mentioned, the first thing, of course, is the prerequisites, right? What do you need? How can you set up in order to start developing with NEAR? Well, to get set up is pretty easy. There are, if you go to the docs.near.org, and I will be posting these links in the description box as well, you can see that there are a couple of links that would help you in terms of how you can, what are the different examples, how can you create your wallet, what is the NEAR Explorer where you can see the transactions. In order to work with contracts, you definitely need to have the NEAR CLI because that is what we are going to be doing today. The NEAR API.js library, if you want to use JavaScript to interact with the accounts and smart contracts. And as I mentioned that the language of our choice is going to be AssemblyScript, we'll need the NEAR-SDK-AS as well, which is the AssemblyScript SDK for developing smart contracts in AssemblyScript, right? So you can refer to this page and make sure that you are installed and set up with all of these requirements. The repo that we will be cloning and working with is the starter AssemblyScript. So I'll be posting the link to this repo as well. Sheriff, who's the education head at NEAR, has been kind enough to prepare this starter kit, which also has a video. If you're interested, you can definitely later walk through this. But just to save some time, what we are going to do is we are going to directly jump into cloning this repo. So I'm going to be copying this link and I'm going to go to my terminal. I've already created a directory. Let me clone this repo. All right. So I've cloned this repo, and now you can see that I'm inside this repo. Let me bring this to the center of the screen so we are all being able to see this. So all right. As you can see, I'm already inside the repo, and you can see that there is a README. There are some config files. There is the asconfig.json, which is config file. Let's take a look at this. So it just has the name of the workspace, that is source sample. So there's a source, there's a yarn.log, which we don't have to worry about. The package.json, of course, it comes with the npm, and there are some scripts which we'll go through soon, right? So let's dive into source. Before that, what I'm going to do is I'm going to just open my VS Code so it becomes easier for all of us to see the code. So as mentioned in the repo here, we need to do yarn, which will install all the dependencies. And then if we want to run the tests, we can do a yarn test, right? So let me just do yarn. So it's going to be installing all the dependencies. As you can see, I already have the NEAR-SDK-AS and some of the other dependencies like the NEAR CLI installed. So this is going to install the this repo specific libraries for me. So let's go inside source and sample. Let's go inside assembly, and you will find a file called index.ts. This is going to be your smart contract file, right? So you can see that once you go inside source, inside sample, which is the name of a folder. For example, if you have a project that is called coin toss demo, you're inside the source, you will create a folder called coin toss demo, inside which you will keep your tests as well as your AssemblyScript contract, which is called index.ts in this case. Now, the next thing on our agenda, of course, was to just walk through this contract, right? So let's see what is there in this contract. As you can see, the first line is importing some libraries. So we are importing from the NEAR-SDK-AS, a couple of data structures, functionalities that we require to use in the contract. So we are going to import the context, which will provide context for the contract execution. As you can see here, it will have information about the transaction sender, about how much money was attached with that particular transaction, etc. Right? And then logging is, of course, used to print out some statements that we are, as you can see, one of the examples, something that we want to log, right, on the console. We can use logging for that. Storage is used to determine the storage related parameters for a contract. So this represents the contract storage, right? And then persistent DQ. So what is persistent DQ? Let us take a look at this. It's a different type of a collection that is built on top of the storage class exposed by the NEAR platform. You will find some other similar collections called persistent vector, persistent map, which you may need to use in your contract as you go, right? So what is this particular data structure that we are using? It's called persistent DQ. It implements queue, a persistent bidirectional queue, that is a double-ended queue or DQ. So you can see here that the syntax to create a DQ is let, then the name of the variable, new persistent DQ, and then what type of DQ do you want to create, a string type. And here we need to choose a unique prefix per account. Why do we need this prefix? As you can see in the node, since all the data that is stored on the blockchain, especially on the NEAR blockchain, is kept in a single key value store under the contract account. Therefore, to determine it uniquely or to access it uniquely, we must use a unique storage prefix for different collections to avoid the data collision. So if you're going to have another collection, for example, persistent vector in the same contract, you will need to pick another unique prefix to identify that particular collection, right? So you can go through this. There are different other collections as well, which you can go through. What are the functions related to this, the constructor, accessors, the different methods, etc. Right? So I'll put a link to this as well in the description box. Now, don't worry about learning all of this in one shot. As we walk through the contracts and write our own contract, we will get to learn more about what these mean, right? So let us, start going through this contract. This is the interesting bit that, we have come across. So the first function that you see in this contract is called show you know, right? It's a view function. That is, it does not alter the state, right? So what do you mean by altering the state? When we store some information on the blockchain, right? In the form of variables, when we are when we are declaring some variables in the contract, right? They have some kind of value associated with them. That is, they are in a particular state. So when we are writing and during write operations, we change the state of these variables. During read operations, we don't do, we just read the state of that variable. So this particular function called show you know is just a simple view function. That is, we are just printing a log statement here and we are not doing anything. So it's not returning anything. So you can see the return type void here. So let me just explain the syntax over here a little bit, and I'll just do that for one function. So you can see that the export keyword is used here to define this function. Function is the keyword, of course, to define the function itself. This is the name of the function. Here, if it takes any parameters, it will go inside the parenthesis, colon, and this is the return type. So we have our curly braces inside which the logic of the function will be written. If we write the keyword export next to it, that means this function can be accessed in an external file as well. Simple as that, right? Here, we are using our logging to log, saying that this particular function was called, show you know was called, right? Now we have another function called show you know 2, which is returning something. So you can see that the void has changed to bool. So this is again logging a statement saying this particular function was called and it returns true. Now, this is a function wherein we are printing something saying say hello, right? Sorry, we are printing that say hello, that is this particular function was called. And we are returning, instead of a bool, we are returning another type of parameter called string, right? So we are returning hello. So when this function say hello would be called, we'd be returning hello as a string, right? This again is a view function. We are not altering the state of any parameters in this function. Now here, what happens in this next function called say my name, right? In this function, we are returning a string, but what is the string that we are returning? We are returning hello, which is a static string populated by us, plus context.sender. If you remember, when I said that we'll be importing context from the NEAR SDK, this will have all the information regarding the transaction. So context.sender will give us the account ID of the transaction sender. So as you can see that it will be printing hello context.sender and then an exclamation mark. So whoever calls this function, the account ID of that sender would be printed here. Let us see what is happening here, right? In the next function called save my name, right? In save my name, what we are doing is we are using the storage, right? Which is going to have the storage of the contract itself. This function will save the sender account name to the contract state. It's not returning anything, but it's going to store the context.sender, that is the sender account name, to the state belonging to that particular contract, right? So here we use the storage keyword. Now, if we see the next function, which is called save my message, right? This is a change function, that is, it is altering the state. It's not taking any, it takes a parameter called message, right? And then it returns something called, it returns a Boolean value. So you can see that the parameter name, colon, the type of the parameter is how the syntax for taking a parameter inside a function would work. right? So we have message, and then the type of the message is going to be a string. So what this, let's see what this function is doing. It is first printing out that this particular function was called. Here, assert is used to check something, right? If this particular condition results to false, then message, if this statement would be printed. So it's checking if the message length is greater than 0. That is, some significant message has been sent. If not, it says that message cannot be blank, right? Now, it is creating a new persistent DQ, right? Called messages of type string. So here the prefix that they have chosen is messages. It is too long. It should actually just be like an M or something, right? But here the name of this persistent DQ, most important, is this messages. And what type of variable will this persistent DQ store? Strings. So all the messages we are storing in this persistent DQ called messages. We are creating a new one, right? In this, we are pushing to the front a new message that we are creating, right? Or rather, we are appending the message that the user has sent with the data of the user. That is, we are creating a new persistent DQ. In the persistent DQ, we are pushing context.sender, that is who's made this call, says added by us, and the message that they have sent. So who has sent what? That will be added to this particular persistent DQ called messages, right? It doesn't return, it returns once the action is over, it is meant to return true, right? So this seems to be a little misleading, but that's fine, right? We know what's happening in the function. Now, let us see the last function that is called get all messages, right? And it returns an array of string, right? Now we are storing, all of our strings in a persistent DQ. So why are we returning an array of strings? This might be a question. Now, AssemblyScript by default supports arrays, right? But persistent DQ is a collection that has been created by NEAR for easily storing the key value pairs on blockchain, right? So that is why we need to take this collection, convert it into a string, and then we can see the values on the console properly. So you can see get all messages returns an array of strings. Of course, it logs get all messages was called. Then we create the persistent DQ, right? Called messages. So since it is persistent, it will of course have all the messages that have been sent by the sender in this previous call. And while it is not empty, it loops through the messages DQ, right? It pops each of the messages and then pushes it in this new array called results that we have created. This is an array of strings. And once the results is populated with all the messages, we return this to see what are all the messages that we have, right? Now that we have gone through all the functionality of the contract, right? I want to show you another, So if you see this folder called scripts, you'll find two scripts inside this. The first one is one.init.sh. This is going to delete if any previous contract instances were there and set to the owner as a beneficial, right? So you can see the first thing it does is delete any older instances and cleans up the NEAR dev folder. And then it will build the contract for us using yarn build release. And then it deploys the contract using NEAR dev deploy. Now NEAR dev deploy creates temporary account IDs for us on which the contract can be deployed. It is important to note that each account in NEAR can hold only one contract, 1 or 0 contracts, but maximum it can hold 1 contract. Now, to avoid all the hassle of creating testnet accounts, etc., the dev deploy command automatically creates an account ID for us. where this particular contract will be deployed. So our contract will be built as sample.wasm, the wasm file from assembly. And then this will be deployed onto the NEAR blockchain, right? Not the main net, of course, the local net that we are working with using the CLI. We can also deploy it on testnet or wherever you would like to, deploy it, of course, but we'll have to change certain parameters for that. So this is the first script that we'll be running to deploy the contract, right? So let's get started. So let me just increase this. So as I mentioned, so missing contract environment variable, I have not set anything. Missing owner environment variable, I have not set anything, right? So I will be setting the owner to my testnet account, that is yarn.testnet. Because my testnet account exists on this system, my testnet account keys. So I can set my testnet account as the owner. Another way to do this is to create, you can create your own testnet account. So if you go to wallet.testnet.near, you can create your own account. I have some, older login confirmation page that has just opened up. Let me. So it's an unknown some app that I was locally building. But you can see that the wallet.testnet.near.org, here automatically my testnet wallet has opened, but you can also create your own testnet wallet. You can create a new account or once you go here and you will have your testnet. And you can use NEAR login to actually log in to this particular testnet. And you can, like you saw the message which said give access to the unknown app. So give access to this particular app. And then also you can set the owner as your own testnet account ID. So the beautiful thing about NEAR is that you don't have to worry about remembering, huge long hexadecimal addresses. Your account ID can simply be whatever name you give, .testnet or .near for mainnet wallet. Super cool, right? So, all right. So as I said, let's look at how the deployment has happened. It has created a dummy account ID for us. That is this, right? And we can see that this is the node that it is connected to, the rpc.testnet.near.org. The transaction ID, we can even see the transaction, the explorer if you are interested. And it is deployed to this particular testnet account. Now, it asks us to set the contract to this particular new ID, right? So it can get this for the next further deployments. I'm also going to go ahead and set myself as the owner, all right? So now that we have deployed the contract, you can see a couple of more things have happened, right? You can see that a sample.wasm file has been built. Then the NEAR dev, there's a dev account that has been created. There are certain, so the contract name is in this account ID. And then there are certain other node modules that have been added, right? So something has happened. Now, the second script, what that something is deployment of the contract, right? That's what has happened. Now, the second script here can be used to call all of these functions that we were looking at in our contract, right? Using the CLI. So let's see what are, how are they calling these? This is going to be just to check if we have set the environment variables, which we have already set on our terminal just now. So here we are going to be calling the view functions, so which don't require a signature, the first three, right? So let us comment these out. So, right, 21. Okay. So here we are going to be calling NEAR view, right? This particular the contract address, right? And then show right? And then all the three functions which are going to be printing some log, right? So So the first function, show you know, right? It says show you know was called and it doesn't return anything. The second one, show you know two, right? It says show you know two was called and returns true, a Boolean value. The third, say hello, right? It just returns hello, right? A string. So let's run the script and see what happens. So you can see contract is set, owner is set. Now it is calling the first ever function, that is view call first. So it returns false, right? Because it's returning void, it's not returning anything. Show you know was called, so it's printed. The second is show you know two was called, that is printed over here, right? And the third is say hello was called and hello is printed. So this one returns true, so true is printed. You can see how can you see what function was being called? You can see the name of the account ID that was created for us, the contract dot show you know, that is the function name that was called, right? So all good so far. All of the view functions have been called. Now let's comment these out. And then 21, 26, and these, right? So let's see what these are doing. So a couple of our other names, other functions. So this is say my name, right? Let's go and see what this is doing. It's calling this function and it needs a context dot sender. That is who is calling this function is going to print that hello context dot sender. So here we have sent an account ID called owner. Now the owner that I have set is gyan.testnet. That is my testnet account. The next is save my name. So the next, it just saves this particular context.sender, as you saw over here, in the storage, right? And the next function, the next two functions are about the persistent DQ, if you remember, right? So we are sending a message called hey again. You can see how the message is being sent from this particular account ID, that is owner. And we get all the messages for this particular account ID owner. So to make it a little interesting, let's send a couple of messages, right? Not just one. Hey again, one maybe, and let's say hey back again. All right. So we're going to be sending a couple of messages and then we're going to be retrieving them back, right? So let's run the script now. All right, so the owner is set. Again, the contract is set. This is the first thing that's being echoed. Now, say my name. So it should say who was the contract caller, right? So let's see what it prints. Okay, it says hello, Gyan.testnet, right? So I was the contract caller, context.sender printed Gyan.testnet. That is my account, right? Okay, here we are not returning anything, just storing it in the storage, right? In this function that is save my name. Now next is save my message, right? So this was successful. The first message was saved, hey again. So it sent me a true. Then I'm saving another message called hey again one. This is also true. Let's see what is the next message. That is hey back again. So this is also true. Now we have saved 3 messages in the persistent DQ, right? According to our functionality. Now we are getting all the messages that are there in the DQ. As you can see, it sends, it prints this particular context.sender says, hey again. Yarn.testnet says, hey again one. And the third message as well. So all of our messages we were able to successfully retrieve from the persistent DQ. So yeah, and just before we close, let's see one of the transactions in the Explorer as well, right? So here you can see that this is get all messages in contract, the contract account ID. Then you can see what was the result, the console log that was printed, right? You can see the different, the block in which it was executed, what was, let's see, what was the gas burnt, the tokens burnt, who is the predecessor, what is the receipt, here is the block hash signed by the owner, the receiver, the status that it succeeded, etc. There's no deposit value associated with it. And you can see the transaction fee as well, which is extremely, extremely low, right? So yeah, I think so. We have gone through this entire contract. We have seen it in action. We have run the contract. So for today's video, we have fulfilled all the purposes that we set out to fulfill. And hopefully, thank you so much, first of all, for joining me and watching this video. Hopefully, you're able to clone this repo, run this contract, and understand what it is doing, right? It is fairly simple, very straightforward. And in the next part, we will learn how to write our own smart contract from scratch. And of course, in the part 3, we will learn how to do the testing. So once again, thank you so much. If you love my video, please make sure that you're able to watch part 2 and part 3 as well. So your entire Build with NEAR series is complete, right? I'm looking forward to seeing you in the next video. Thank you so much. Stay safe and stay healthy.